Now, earlier on, we had seen a use case wherein you could go ahead and use Docker Compose to go ahead and deploy multiple containers. So this is a technology that's available with Docker. When it comes to Azure, they have another service that is known as Azure Container Groups. So over here also, you can go ahead and deploy a collection of containers. Here, the containers get scheduled on the same host machine. The containers in the container group actually share the lifecycle, the resources, the local network, and the storage volumes. Now, the deployment of the container group can be done via a resource manager template or a YAML file. And from the perspective of the exam, it's important to understand the deployment via a YAML file. So over here, the entire service is used to go ahead and deploy a set of containers that will be running on the Azure Container Instance service. Remember, this service will automatically go ahead and provision the underlying compute infrastructure right for running your containers. Now, in the next set of chapters, we are going to go through some use case scenarios which are important from an exam perspective when it comes to Azure Container Groups. Now, the first thing I want to show you before we actually go ahead and deploy a container using the Azure Container Group is how to create a custom image when it comes to an image that is already available for MySQL. So we've looked at Docker Compose. We have seen at how you can actually go ahead and send out initialization data for your MySQL database. So if you want to go ahead and create a table, if you want to go ahead and insert data, you can go ahead and use Docker Compose. Now, you could also go ahead and use Docker Compose when it comes to Azure Container Groups. But when it comes to the exams, you'll normally be using the YAML configuration for the deployment of Azure Container Groups. So over there, there's a different outline on how you specify statements. The YAML configuration is different when it comes to Azure Container Groups. So the first thing I want to show you is how you can create a custom MySQL image so that you can actually go ahead and use that as your image when you want to go ahead and deploy a custom MySQL container. Over here, I have a folder. This is on my local machine. In that folder, again, I have a SQL script. Over here, the same thing, creating a table and inserting data into the table. Over here, I have a Docker file. Now, in the Docker file, I'm saying, please go ahead and use the MySQL image, which is available from Docker Hub, has the base. Over here, I'm specifying what should be the MySQL root password and what should be the name of the database to create. And then over here, I'm using the copy command to go ahead and copy my SQL script onto the entry point. Remember, this is the entry point which is run when the container is first launched. So over here, now I'm creating my own custom image, which has everything in place, my data already in place. So over here, we are going to go ahead and use these commands to create that custom image. So over here on the Ubuntu session on my local machine, I'm in my mnt/c/temp2 folder. So over here, let me go on to the custom MySQL folder. Over here, I have my Docker file in place. So I'll go ahead and first build now an image based on the instructions in that Docker file. So it's done. Now let me go ahead and run a container based on that image. I want to go ahead and verify that the image is working as it should. So I want to go ahead and connect on to a running container. Now over here, I can see that I have an error in place, and that's probably because I already have some containers running in the background. So let me go ahead and first stop all of my running containers. So I'll go on to Docker containers stop, and over here 9790, and the other one is 3714. So 3714 and 9790. Now let me go ahead and try to run it again. Now I should already be having that actually container in place. Let me go ahead and do a docker ps-a. So I already have my custom SQL container in place. The only thing it's not running. So let's go ahead and start that container. So start. Over here, I'll say custom SQL. So the name should be app SQL. Sorry, my mistake. Right, so now we have the container in place. Now I can actually go ahead and interactively log into the container. Right, so now I'm in the container. Now let me do a MySQL and log. Into MySQL, and let me confirm. So let me go ahead and use appdb. Let me go ahead and select star from courses. Sorry, from course, and over here you can see our data in place. So we now know that our custom image is working as it should. Now I want to go ahead and publish the image that we just created onto Azure Container Registry. So I have a registry running in Azure. So over here, if I do a Docker image ls, over here I can see my custom SQL image in place. So the first thing I'll do is to go ahead and tag my custom SQL image. Then I need to go ahead and log into Azure Container Registry from here. So for that, I'm first going to go on to the Microsoft documentation to go ahead and install the Azure CLI, basically on Linux. So I'll go on to the Ubuntu section. And over here, I'll just go ahead and copy paste the commands which are required to go ahead and basically install the required packages. So going on with the second package as well. So it's a simple copy paste from the Microsoft documentation. I'll go on to the next, just copy it from here. Paste it in my session, hit on enter. Go back, do a copy from here. Hit on enter. Then go ahead and again copy these statements. And now it will go ahead and install the Azure CLI. Let's wait till this is complete. Now, once this is complete, let me go ahead and just clear the screen. Now over here, let me do an AZ login. Over here, I'll say go ahead and use device code. So now in order to authenticate onto Azure CLI, I'm going to go ahead onto Microsoft.com, device login, and I'll go ahead and manually enter this code. So I'm going on to Microsoft.com, device login. Over here, I'll enter the code. So I've entered the code, I'll go on to next. So I'll go ahead and choose my account. So it's saying I'm logged in. So over here also I can see that I've logged in. Now let me go ahead and push the image onto the Azure Container Registry. So I'll go ahead and again clear the screen. And let me go ahead and push my image. Now I need to go ahead and log into my Azure Container Registry. So I'll do an AZ-ACR login, and I have to give the name for my registry. So over here in Azure, I have this as the registry name. So let me go ahead and choose this registry name. Once I've logged in, now let me go ahead and push my custom image onto my Azure Container Registry. Now, once this is done, if I go on to repositories, over here I can see my custom SQL image in place. So now in the last chapter, I talked about Azure container groups. Now let's go ahead and see how we can use a YAML deployment to go ahead and create an Azure container instance within an Azure container group. So again, remember the Azure container group is nothing but a collection of containers within the Azure container instance itself. Now I'll go ahead and start simple. We'll just go ahead and deploy one container as part of our container group. And then in the next chapter, we'll go ahead and see how to deploy two containers as part of an Azure container group. So again, there is a particular definition that you need to follow when it comes to YAML, when it comes to the Azure container group. Basically, what are the name value pairs in the YAML configuration? So firstly is the name that is going to be given onto your Azure container instance itself. Then in the properties, you go ahead and mention your containers. Over here, you're just giving a name for the container. And then in the properties, you're going ahead and specifying what is the image. So earlier on, remember that we did go ahead and create a custom image in one of our registries. So if I go on to my repositories, so over here I can see my custom SQL image in place. So we're going ahead and using that same image over here. Then in the resources section, I'm saying please go ahead and allocate one CPU and 1.5 gigs in terms of memory. And I'm saying please export port 3306. Over here, I'm saying please use the underlying OS as Linux. That is the compute that will be used for hosting my container. And then you need to go ahead and give what are the credentials for your registry, because the Azure container instance needs to go ahead and pick it up from the Azure container registry. So for that, you actually have to go onto your access keys for your registry. Over here, you can actually go ahead and copy the login server, what is the username and the password. So that's what I've done. I've gone ahead and copied the server name, what is the name of my registry, what is my username, and what is the password. Now let's go ahead and deploy this YAML file. So now in another tab, I've gone on to Azure Cloud Shell. Let me go ahead and upload that file. So I'm going ahead and choosing the containers DB YAML file. I'll go ahead and click on open. Right, so I have the file over here. Then I'm going to go ahead and issue the command of AZ container create. Over here, I'm mentioning the resource group for my container instance. And then in the file, I'm mentioning the name of my YAML file. Let me go ahead and hit on enter. So remember, in the end, it's still going to go ahead and create an Azure container instance. Over here, we're going ahead and giving a YAML definition for the creation of this Azure container instance. Let's come back once the deployment is complete. Now, once the deployment is complete, so in another tab, if I go on to all resources, over here, if I go ahead and search for instance, so over here, now I can see I have my app group container instance in place. So remember, the name that you give over here will go ahead and give the name for your Azure container instance. Over here, if I go on to containers, I can see that my container is running. Let me go ahead and just hide this. Over here, I can go on to the properties. I can see the properties of the container. If I go ahead on to connect, over here, let me go ahead and hit connect. So over here, I can actually go ahead and log into MySQL. And over here, we can see, or you can see that we are connected. So in this chapter, just want to kind of go ahead and show you how you can do a simple deployment via a YAML configuration. This is known as deployment of Azure container groups. Now, in the last chapter, we had gone ahead and seen how we could go ahead and deploy a simple container instance with just one container using a YAML deployment. Now, in this chapter, let's go ahead and see how we can do deployment of multiple containers using YAML to an Azure container instance, basically onto an Azure container instance group. So firstly, let me go ahead and delete the existing group that we have in place. So let me go ahead and hit on delete. This is the one that we created in the last chapter. Right, so let's go back onto our YAML configuration. So over here, we have again the name of our Azure container instance group. Again, in the properties, we have the containers. So I have my database container. And now over here, if you go ahead and scroll down, I'm going ahead and giving a name for another container. In the properties, I'm actually going ahead and mentioning now what is the image repository for the web application, the ASP.NET Core web application that will actually go ahead and connect onto this MySQL database server. Over here, again, in terms of the resources, I'm giving the same amount of resources. Over here, I'm saying please go ahead and expose port 80 when it comes to the container. Again, the OS type is Linux. Now in the IP address, I'm saying please go ahead and also associate a public IP address onto the Azure container instance group. And over here, I'm saying please go ahead and expose port 80. And the rest remains the same. Now, when it comes to my application, so I've already gone ahead and ensured that I have deployed basically that has an image onto my Azure container registry. So something that we've also seen in earlier chapters. So if I go onto my container registry, if I go onto my repositories, so over here I have that SQL app in place. Now if I go back onto my program, so again this is the same program that is used to go ahead and display a list of courses connecting onto a MySQL database server. Over here, the most important thing that I've noted is that I need to go ahead and understand what is the value I need to go ahead and give onto the server. Because if you go ahead and if you don't give a proper value for the server over here, when you go ahead and actually try to connect onto the MySQL database, it'll go ahead and give an error of an unknown host. Now, obviously, depending upon the platform. So remember, Docker has a different way of exposing containers. Then you have Kubernetes. Then now you have Azure container instances. So again, there's a different way in which they go ahead and expose their containers. So over here, this is through R&D basically. I've understood that in order to go ahead and actually connect on to the MySQL database server, I need to go ahead and mention localhost. And because these containers are actually running on the same host machine, so your Azure container group in the end, remember, goes ahead and deploys your containers within the group on the same host machine. So I can go ahead and mention local host basically has my server. So this will actually go ahead and point on to that same compute instance that is hosting my MySQL database itself. So this is the most important thing. When it comes to the connection string, what is a server that you need to connect to? This is important. Otherwise, everything else remains the same. So I've gone ahead and published this particular ASP.NET Core application has an image onto my repository. So now let's go ahead. Let me go on to Azure CLI. Let me go ahead and clear the screen. Now let me go ahead and upload the other file as well. So now I'll choose containers app. So over here, let me go ahead and rename this as containers app.yaml, and let me go ahead and hit on enter. So now remember over here, our Azure container group will actually contain two instances. One is for our database and the other is for our application. Let's come back once this is complete. Now, once the deployment is complete in all resources in another tab, let me go ahead and hit on refresh over here. So again, I can see my app group in place. If I go on to my containers, so let me go ahead and hide this so I can see both are in the running state. So if I go ahead onto the overview, let me go ahead and take the public IP address. Let me go on to the IP address itself in another tab. And over here, you can see our ASP.NET Core application. It is going ahead and connecting onto the MySQL database to go ahead and get the information. Now, when it comes to debugging, so the best way to go ahead and debug if something is going wrong, so you can go ahead and basically, attach onto the container to go ahead and see the logs. Also in the Azure portal, if you go onto your containers, if you go ahead onto the logs, so over here, you can see all of the logs in place. You just have to go ahead and choose your container. So if you go ahead and choose your web container, so you'll see the logs for your web container over here. So if there are any issues, if there are any exceptions, you will see it over here. So you can actually go ahead and debug what's happening in your containers via the logs over here. Hi and welcome back. Now in this chapter, I want to go ahead and show you how you can use the Azure container instance to persist data onto a volume. So in our case, let's say we want to go ahead and run an ASP.NET Core application has a container in Azure container instances. Let's say this application is going ahead and downloading a blob from a storage account. So remember again, in the concept of containers, the data in the container is not persisted. When the container is deleted, then the data is also not present. But with Azure Container Instance, you can go ahead and persist that data. Over here, you can actually go ahead and create a file share in an Azure storage account. And the container can go ahead and mount a volume using that file share. So now all the data can actually be stored in the file share itself. So for persisting data, Azure Container Instance has support for using file shares. So let's see how we can accomplish this. So over here, I have a simple console-based .NET Core application. This application is going ahead and getting a blob from a storage account. So in Azure, I have a storage account in place. Over here, I have a data container, and in the container, I have a file known as courses.json. Over here, if I go on to edit, I can see the contents of the file. So all this program is doing is that it's going ahead and using the connection string of that storage account, going on to the container, taking the courses.json file, and it'll go ahead and download the file. Now over here, when it comes to the path, so I'm going to go ahead and show you the YAML configuration for the Azure container group that we're going to go ahead and deploy. And over there, we're going to go ahead and specify this as the mount point that will actually point onto a file share. The first thing I am going to do is that let me go ahead and publish this onto an Azure container registry. So in Azure, I have an Azure container registry in place. Currently, I just have two repositories over here. So let me go ahead and publish my project. Over here, I'll choose Docker Container Registry. I'll go on to next. I'll choose Azure Container Registry. Over here, let me go ahead and choose the registry and hit on finish. And then let me go ahead and hit on publish. So this will go ahead and publish our project has an image onto the Azure Container Registry. Now, once the deployment is done, if I go ahead and hit on refresh in my repositories, over here, I can see my image in place. Now over here, let me go on to Visual Studio Code. I'll go on to the containers.yaml file that I will be using for deploying my Azure container group. So over here, I'm giving the name of the group. Over here, in terms of the properties, I'm going ahead and giving a name for the container. Over here, I'm saying to go ahead and pick up basically the container from my Azure container registry. Let me go ahead and ensure that I have the correct name for the Azure container registry over here. The name of the image is blob project. It's the latest tag. Over here, now in terms of the volume mounts, I'm saying please go ahead and use a file share volume. So this is the name I've given on to the volumes which I've defined in my volume section over here. So here is where I specify the mount path has app data. So I'm storing that downloaded blob onto the mount point that is app data. Now, if I go on to the volumes over here, I'm giving a name for the volume. I'm specifying the volume is based on the Azure file share. Over here, I have to go ahead and create a file share. So what I can do is that I can go actually on to the same storage account just for the purpose of this demo. I'll go on to file shares. Over here, let me go ahead and create a new file share. So it needs to be container share. So over here, I'll give the name of container share and a quota, and let me go ahead and hit on create. Now next, I need to give the name of the storage account and what is the storage account key that will be used for authorization. So let me go ahead onto the storage account. I'll go on to access keys. So over here, let me go ahead and copy the storage account name. So I'll place it over here. Then I'll go ahead and copy either key 1 or key 2. So I'll copy key 1. I'll go ahead and replace it over here. And next is what are the credentials to connect onto the Azure container registry. So I'll go on to my Azure container registry. So I'll go on to my Azure container registry. I'll go on to access keys. Over here, let me go ahead and take the login server name. And let me replace it over here. Then I'll take the username and the password. So I'll take the username from here and I'll copy it over here and take the password. So over here, this is the password. So I'll replace this entire thing. Right, so let me go ahead and save everything. So now quickly, if I go on to my storage account, so if I go on to the file shares, if I go on to container share, so currently I can't see any files in place. Now in another tab, I have Azure Cloud Shell in place. Let me go ahead and just clear the screen. Now let me go ahead and upload that YAML configuration file. So I'm going on to my local directory. Over here, I'll go on to container group file share. And let me go ahead and upload the containers.yaml file. Then let me go ahead and create that container instance using this YAML file. Right, so this will go ahead and create the container instance. Let's come back once this is complete. Now, once the deployment is complete, I'll go on to a new tab. Over here, let me go ahead and search for instance. So I can see my app group container instance. Over here, let me go on to my containers. So over here, it's terminated, and that's fine. That's because it just had to go ahead and download a blob. It didn't have to do anything else. If I go on to the logs, so over here, you can see that whatever I wrote to the console is being shown in the logs over here. If you actually go on to the properties, and if you go ahead and scroll down, over here, you can see the volumes that have been mounted. So you have an Azure file share. And now if I go onto the file share and if I go ahead and hit on refresh, I can see my courses.json file. So over here, we are now going ahead and persisting data for the container using an Azure file share. Now in this chapter, I want to show you how you can securely go ahead and access secrets within your containers. Now, earlier on, we had seen how we could go ahead and basically download a blob onto a file share. So we had gone ahead and mounted a volume. Now, in that previous program, we were going ahead and using a connection string to go ahead and connect onto our storage account. But let's say I don't want to go ahead and embed the connection string within my program. I want it to be as a secret in my Azure container group. And I want to go ahead and have the ability to go ahead and pick up the secret at runtime and then go ahead and run my program. So over here, if you look at my program, I don't have now the connection string in place. Over here, let me go ahead and just change the name of the blob onto courses.json. That's what we had looked at earlier on. And over here, now I'm making a reference onto a secret, which will be available based on my Azure container group. So I'll be seeing this a little bit later on. Over here, this is how I'm going to go ahead and get the value of the secret. So the secret of storage connection is going to go ahead and hold the connection string for my storage account. Then within my program, I am just going ahead and reading the storage connection secret. Over here, it will be stored as a file. So over here, that storage connection file is going to go ahead and have the storage connection string for my Azure storage account. And then everything remains the same. So the first thing I'm going to do is to go ahead and do some cleanup. First of all, in my file share, let me go ahead and delete this file because we're going to go ahead and run the program again. Then I'll go on to my container group. Let me go ahead and delete this container group. Then let me go ahead on to my container registry. So I'll go onto my app registry. I'll go onto my repositories. Let me go ahead and delete this repository of blob project. And over here in Visual Studio, let me go ahead and publish this onto the Azure container registry. So over here, I'll go ahead and choose Docker container registry. I'll go on to next. I'll choose Azure container registry. I'll go on to next. Over here, I'll go ahead and choose the application registry. And over here, let me go ahead and hit on publish. Now, once the publish is complete, if I go on to my repositories and I click on refresh, so over here, I can see again my image in place. Now over here in Visual Studio Code, so I have another YAML configuration file for the deployment of my container group. So over here, I'm giving the name of the container group. Again, I'm going ahead and specifying what is the repository from where to pick up my image. So again, over here, let me ensure that I have the correct name for the container registry in place. Over here, this is my image. Now, in addition to the volume mounts path we have over here, I also have now another mount path for storing the secrets as well. So over here, I have another volume with the name of volume secret. So if I go ahead and scroll down over here in my volumes, over here, the name of my volume is volume secret. And over here, I need to go ahead and give what is the name of the secret I want to go ahead and store. So I want to go ahead and store the connection string. So what is the connection string that I want to go ahead and store? So if I go on to my storage account, if I go on to access keys, if I go ahead and show the keys, so I want to go ahead and store now this connection string. But if you go ahead and look at the value over here, so this value is basically in encoded format. So we have to go ahead and first encode the connection string and then store the value over here. Now, before I go ahead and do this, let me go ahead and ensure to update all of these contents so that it reflects the details of my storage account and my Azure container registry. So once I've gone ahead and made all of the required changes, let's go ahead and get now an encoded version of our connection string. So over here, I have a PowerShell script that we can actually go ahead and create the encoded version of the connection string. So over here, let me go ahead and get the current value of the connection string. So I'll go on to my storage account. I'll go ahead and copy the connection string over here. I'll paste it in the value. Next, we are going ahead and getting basically the bytes of the connection string. Then we are going ahead and converting it on to base 64 encoding. And then we can go ahead and write the value. And that value, we can go ahead and write it as a secret onto our Azure container group deployment. So let me go ahead and copy this. Now I can go on to Azure Cloud Shell that I have in another tab. So let me go ahead and right click and paste that particular value. Then I'll go ahead and get the bytes. Then I'll get the base 64 string. And then let me go ahead and write the value. Right, so let me go ahead and now copy this. And I'll go on to Visual Studio Code and I'll replace it over here. So this is a requirement. If you want to go ahead and store the secrets, this is how you would store the required value. You would then go ahead and automatically get the actual connection string. You don't need to go ahead and, decipher the bytes again, decipher the strings. No, this will be done automatically for you. So now let me go ahead onto my Azure Cloud Shell. Now over here, let me go ahead and again clear the screen. Now over here, I already have a containers.yaml file. So let me go ahead and delete that file so I don't have it anymore. Now let me go ahead and upload my containers.yaml file. So I'll go on to container group secrets. I'll go on to my containers.yaml file. And let me go ahead and again do the deployment. So over here, remember the biggest difference is that our program is going to go ahead and now get the connection string, which is stored as a secret in Azure container groups. Then it'll go ahead and follow the same process where it'll go ahead and download a blob and store it in our file share. Now, once the deployment is complete, if I go on to my storage account, let me go on to file shares. I'll go on to my container share. And over here, again, we can see our courses.json file. So remember over here, we did not have the connection string in our program. It got the connection string via a secret from the Azure container group. Hi and welcome back. Now in the next set of chapters, we are going to be looking at how we can deploy containers onto Azure Kubernetes. Now Azure Kubernetes is just a managed version of the Kubernetes tool itself. So Kubernetes is actually used to go ahead and manage containers at scale. And Azure Kubernetes is just a managed service for Kubernetes itself on Azure. So companies will actually go ahead and develop applications has a lot of containers. And once you start having many containers in place, trying to go ahead and manage them is quite a challenge. Even for me, if I'm developing a very simple application that just contains 2 or 3 containers, trying to manage all of them when it comes to deployment, when it comes to scaling, when it comes to ensuring they're always up and running can be a challenge. So then you can go ahead and use the Kubernetes tool. This tool can be used to go ahead and deploy your containers at scale. It can also go ahead and perform other features such as load balancing requests onto your containers. It also has the ability to go ahead and ensure containers are always up and running. So Kubernetes can be used to orchestrate your containers for hosting your applications. So your application might have different containers. So it might have one container that is hosting the web layer of your application, one more container that is hosting the logging part of your application, let's say another container that is hosting MySQL, and another container just for hosting the business layer. And this comprises of your application. You can actually go ahead and deploy those containers as an application onto something known as a Kubernetes cluster. The cluster is responsible for ensuring that these containers run on underlying nodes. So when your application contains many containers, instead of trying to go ahead and deploy them one by one, you can go ahead and deploy them as a set, as an application onto your cluster. Now, if you look at a Kubernetes cluster, so if you just look at the different parts of a cluster, you have something known as the master node, and then you have the other nodes that are used for hosting your containers. The Kubernetes service or the Kubernetes software will actually be installed on both the master node and the other nodes as well. These nodes are basically virtual machines. So in Azure, these virtual machines are going to be managed for you. Even the master node is going to be managed for you as well. When you go ahead and create a cluster, all you go ahead and do is tell what should be the configuration of these nodes. So what should be the instance type? How many nodes do you want to go ahead and spin up as part of your cluster? So all of your containers are actually going to be running on these individual nodes. The master node is used to just go ahead and ensure that the nodes do the required work of hosting the containers. All of the calls onto the cluster. So let's say you're submitting an application to be deployed as containers. That call is actually made onto the master node. The master node will then go ahead and redirect the request onto the nodes in the cluster. There are many parts of the master node. So there is the API server. So I said all of the calls onto the cluster goes to the API server. You have something known as etcd, which is the cluster store that is used to go ahead and store the state of the cluster. And when you look at the different things that are actually installed on the individual nodes, so you have kubectl. So this is a Kubernetes agent that runs on the node. It's responsible for registering the node with the master node. It takes the commands from the master node for deployment of the containers. On the node, you also have the container runtime. This is used to actually take the image and deploy them as containers on the node. And then you have kubeproxy. This is used for managing the networking aspects of the container. So let's start to go ahead and give you an overall picture first of Kubernetes itself before we actually dwell into Azure Kubernetes. So now before we actually go ahead, create our Kubernetes cluster and deploy our containers, let's just have some quick short chapters on some important terms when it comes to Kubernetes. So first is the deployment of containers. So over here, if you're looking at a unit of deployment of a container, then it is referred to as a pod. So the pod actually becomes part of something known as a deployment, and that deployment is done on a node in the cluster. Over here, the unit of the deployment, the initial unit of a deployment is called a pod. Now, a pod is used to group either one or more containers. So you could either have one container as part of the pod or multiple containers. You can just go ahead and just have one container as part of a pod. The pod gets shared storage and network resources. If you do go ahead and deploy multiple containers as part of a pod, then they need to go ahead and listen on different port numbers, because each pod gets an internal IP address. So if you want to go ahead and have multiple containers that are listening for requests, then they need to go ahead and listen on different port numbers. Right, so in this chapter, I just want to have a quick review of the concept when it comes to a pod. Now, in the last chapter, I just quickly gone through the concept of the pod. Now the pod can be part of a deployment. Now the deployment is basically a declarative way to describe the state of the pod and the replica sets. In the Kubernetes cluster, there's something known as a deployment controller that is used to ensure that the desired state of the environment is always met. And this is something that is very important. This is something that makes Kubernetes very unique. So for example, let's say you add a very simple application that is running as a container. Let's say you have one single container. It's basically a web application that is being hosted in this container. Let's say this is part of a pod. Now let's say if you have a lot of requests and they need to be load balanced across, let's say, multiple pods that are hosting the same type of container. So this is like load balancing your requests across different instances of your application. So Kubernetes has the ability to go ahead and load balance the request across different pods in your deployment. Now, when it comes to the deployment, you can say that I want basically a minimum of 3 pods that are always running. If in case one pod goes down for any reason whatsoever, the deployment controller will go ahead and quickly spin up a new pod. You don't have to go ahead and tell it to spin up the new pod because you've gone ahead and mentioned this as part of the deployment. The deployment controller has its states over here, is used to ensure that the desired state of the environment is always met. And over here, if you go ahead and mention the desired state of the environment to be 3, it will always ensure that 3 pods are running. Now in this chapter, let's go ahead and deploy a Kubernetes cluster. So over here in all resources, let me go ahead and click on add. So over here, let me go ahead and search for the service. So I'll go ahead and choose Kubernetes service. I'll go ahead and hit on create. Now over here, I'm going to go ahead and create a new group. So the reason I'm creating a new group is because the deployment does create a lot of resources because it will go ahead and create the underlying nodes. Each node has a network interface. So there are artifacts that actually get deployed, and let's go ahead and deploy it onto a separate resource group. So I'll go ahead and hit on OK. Now over here, let's go ahead and give a name for the cluster. So it'll go ahead and deploy a cluster of nodes. I'll leave the region as it is. Just for this point in time, I do want to go ahead and spread this across availability zones. If you want higher availability for the nodes of your cluster, you can go ahead and use availability nodes. I'll go ahead and choose what is the default version it is giving me for Kubernetes. Then I'll go ahead and scroll down. Now over here, you can actually go ahead and decide what is the size of the node. Remember, this is a managed service, right? So all of your containers are going to be deployed by Kubernetes onto these nodes. So these nodes over here, you can go ahead and choose what should be the size of the node and how many nodes do you want. Since this is just a demo, I'll go ahead and just choose 1 node. If you want, you can go ahead and change the size of the node. I'll just leave it as it is. Over here, you can actually go ahead and basically choose the integration with an Azure Container Registry. So over here, I do have a registry in place. So let me go ahead and choose that. So over here, if I go on to another tab, I can see my Azure Container Registry. Now let me go on to next for the node pools. So it'll go ahead and create 1 node pool, which has basically 1 node of that node size. You can go ahead right now or even later on create additional node pools. Now I'll leave everything as it is. I'll go on to next for authentication. I'll leave everything as it is over here. I'll go on to next for networking. So accept the defaults when it comes to networking. Go on to integration. So it'll go ahead and create a log analytics workspace. When it comes to monitoring, I'll leave it as it is. I'll go on tags. I'll go on to review and create. And let me go ahead and hit on create. Now it might take around 10 minutes or less for the cluster to be in place. So let's come back once this is complete. Now, once your cluster is in place, you can go ahead onto the resource. Now over here, you can actually go ahead and deploy your pods as workloads over here, right? So you have your deployments, you have your pods, you have replica sets, etc. And then you can also go ahead and deploy something known as services. Right, so at the moment, let's mark an end onto this chapter wherein we have gone ahead and deployed our cluster. Now, in the last chapter, we had gone ahead and deployed an Azure Kubernetes cluster. Now, in this chapter, let's go ahead and perform a simple deployment wherein we are going ahead and deploying containers based on the NGNIX image. So over here, I have a YAML deployment file in place. We can actually go ahead and submit this YAML deployment file onto our cluster, and then we'll have NGNIX containers in place. Over here, I'm going ahead and specifying what this file is going to do. So this YAML file is basically going to go ahead and do a deployment. And then you have metadata about the deployment. Over here, we're giving a name for the deployment. You can actually go ahead and attach a label onto this deployment. These labels can also be used for other artifacts in your deployment as well. So at the moment, I'm keeping a very simple label. So this is a name pair of values. Over here, we have the name as app, and over here, the value has NGNIX. Then I'm going ahead and now giving the specification of the pod that will be part of the deployment. Over here, I'm saying I want to have 3 replicas of the pod in place. Over here, again, I'm going ahead and specifying that same label. Then if you go ahead and scroll down, here is where you go ahead and specify what is a container that needs to be deployed. Over here, I'm giving the name of the container. And over here, if you want to go ahead and use a specific version of NGNIX, let's go ahead and use the latest version of NGNIX. Now I can go ahead and copy all of this. I can go on to my cluster. Over here, I can go on to workloads. And then I can go ahead and click on add. So over here, I can go ahead and paste in the YAML deployment. And let me go ahead and click on add over here. Right, so it's going ahead with the deployment. Let's wait till this is complete. Now I waited for a minute or two. Let me go ahead and hit on refresh. And now I can see my NGNIX deployment in place. If you go ahead on to the deployment, over here you can see the number of replicas. There are 3 that are desired, there are 3 that are updated, there are 3 in total, and there are 3 that are available. If you actually go ahead and scroll down, you can see all of the pods running over here. If you go on to the events, you'll see all the events that are pertained onto the deployment. So currently we have gone ahead and deployed basically pods onto our cluster. These pods are just running a single container that is based on the NGNIX image. Now, in the previous chapter, we had gone ahead and defined a replica set of 3 pods. There we were going ahead and creating containers based on the NGNIX image. Now, let's say that you want to go ahead and now hit these containers from the outside world. You want to go ahead and have the ability to reach the NGNIX homepage. So now you have to go ahead and basically create a service in front of this deployment. Now, there are different types of services in place when it comes to Kubernetes. You can go ahead and use the load balancer as a service. The load balancer will be allocated a public IP address. So then you can go ahead and make requests on the public IP address, and this service will automatically go ahead and load balance the request across the 3 pods. Again, to go ahead and deploy a service, we're going to go ahead and use a YAML configuration file. So over here, I have a very simple service deployment. Over here, the kind of deployment over here now is a service. Again, I'm giving a name for the service. Over here, the type of service is the load balancer. Over here, I'm going ahead and specifying what port we should be listing on. That's port 80. And over here, I am selecting basically my label. So remember, I had gone ahead and specified basically labels for the pod deployment. We can go ahead and now reference that same label over here. So let me go ahead and copy all of this. Now let me go back onto my cluster. I'll go on to services. Let me go ahead and add a service. I'll go ahead and specify the deployment. And over here, I'll specify the YAML code. And let me go ahead and click on add. Right, so let's wait till this is complete. This will just take a couple of minutes. Now, after waiting for a couple of minutes, let me go ahead and hit on refresh. And I can see my NGNIX service in place. I can now see it has also been allocated an external IP address. So let me go ahead and click on this. And over here, you can see the home page. So now my requests are being directed onto my NGNIX deployment. So if you want to go ahead and expose your pods onto the outside world, you can go ahead and create a service. Now in this chapter, I want to go through the deployment now of two containers onto our Kubernetes cluster. So one container will be based on the custom MySQL image we had built earlier on. We had gone ahead and sent that onto the Azure Container Registry. And over here, I have the .NET application, which you've seen before, that is used to go ahead and basically connect onto the MySQL database. Now over here in the connection string, so I have the user has the root, the password has Azure@123, and database has appdb. Now over here, my server is MySQL, and I'll go ahead and explain this later on because I said understanding the host to connect to is very important. But the first thing I want to do is to go ahead and publish this as an image onto my Azure Container Registry. So I do have an Azure Container Registry in place. Let me go on to the repositories. So over here, I have my custom SQL image in place. So let me go ahead and publish this onto the container registry. So I'll choose Docker Container Registry and hit on next. I'll go ahead and choose Azure Container Registry and hit on next. I'll choose my registry and hit on finish. And now let me go ahead and hit on publish. So let's wait till this is complete. Now once the publish is complete, if I go ahead and hit on refresh, so I can see my SQL app image in place. Now let me go on to Visual Studio Code. Now over here, I have a mysql.yaml file. This will be used for the deployment of the MySQL containers in our Kubernetes cluster. And then I have an app.yaml file. This will actually go ahead and deploy our .NET Core application. First, let me go on to the MySQL deployment file. Now over here, I have two things in the file. First is the deployment of a service and the other is the deployment of our pods. So over here in the deployment of the pods, everything remains the same. The only difference is that I'm going ahead and making a reference on to our custom SQL image in our Azure Container Registry. Over here in terms of the labels, I'm going ahead and giving a label of app and MySQL. Over here in terms of the service, I'm going ahead and exposing port 3306. But over here, I am not going ahead and using a load balancer because I want to go ahead and use a load balancer for my app.yaml file and not for my MySQL database deployment. So it will still go ahead and expose this service so that we can go ahead and connect onto the service from our app.yaml based application deployment. So over here, the name of the service I'm giving is MySQL. And that's why in the Visual Studio Code, if I go onto my course service class, over here, the server I'm giving is basically the name of the service I'm deploying, and that's MySQL. So that's from where I got the name. Right, so this is from the MySQL deployment. If I go on to my app.yaml file, so over here I have a deployment for my application. Over here the container port is port 80. Over here I'm making a reference on to the .NET Core application deployment we just made as an image onto the Azure Container Registry. And then I'm going ahead and using now a load balancer as a service, and I'm going ahead and exposing port 80. So let's go ahead and deploy these workloads. So I'll go on to the MySQL YAML file. I'll copy everything. I'll go on to my cluster. Now what I'll do is that the first thing I'll do is to go ahead and delete the existing NGNIX service and workload that I have. So I'll go on to my service. I'll go ahead and hit on delete. So I'll confirm the delete process. Then I'll go on to my workload. And let me go ahead and delete the NGNIX deployment. Once this is done, now let me go ahead and add a workload. And in the YAML file, I can go ahead and add both the service deployment and the deployment itself of the pods. Let me go ahead and click on add. So it's going ahead and creating basically two. One is a deployment and the other is the service. Let me just wait for a minute or two. Now, after waiting for a minute or two, let me go ahead and hit on refresh. So I can see my MySQL deployment is complete. If I go on to the services, I have the MySQL service in place. Now, let me go ahead onto my app.yaml file. I'll copy everything. Let me go ahead and again add a workload. So let me go ahead and click on add. Over here, let me go ahead and add the YAML configuration and click on add over here. So it's going ahead and creating the deployment and the service. So let's come back after a minute or two. Now I waited for a minute or two. Let me go ahead and hit on refresh. So I can see my app pod basically in the ready state. If I go on to my services, I can see my app service also in the ready state. Let me go ahead and open the external IP address. And over here, you can see the list of services. Right, so we have gone ahead and seen how we can do now our application deployment onto the Kubernetes cluster. Now, in this chapter, I just briefly want to go through the kubectl tool. So this is a tool that is actually already available within Kubernetes. This can be used to go ahead and issue commands against your cluster. So in the earlier chapter, we already have seen how to go ahead and deploy a cluster. We went and also deployed a service and a workload, basically a deployment. Now over here in Azure Cloud Shell, let me go ahead and just clear the screen. Now over here, I have some commands in place. The first command is to go ahead and get the credentials of the cluster using the AZ-204 command. So this is the Azure Kubernetes commands for Azure command line. Over here, you have to go ahead and give the name of the cluster. Now our cluster is part of a different resource group. So if I go on to the overview, it's basically part of the Kubernetes group. So let me go ahead and copy that. Let me go ahead and place it over here. So this will allow us to go ahead and interact with the cluster. So over here, let me right click and paste the command. Right, so that is there. Now you can actually go ahead and issue different commands. So if you want to go ahead and look at the nodes that are running as part of the cluster, you can go ahead and issue the kubectl get nodes command. You can also get all of the pods. So over here, you can see a one node that is running. If you want to go ahead and look at all of the pods, you can go ahead and do that as well. So you can see you have 3 pods that are running. Next, if you want to go ahead and look at your deployments, so that is also possible. So you have 3 deployments in place. If you want to go ahead and look at your services, so you have 1 deployment in place. If you want to go ahead and look at your services, you can go ahead and see your service. So you can see the load balancer service that we have. Now, please know that using kubectl, actually, you can go ahead and also manage various aspects of your cluster. So you can go ahead and deploy your pods. You can go ahead and deploy your services. You can go ahead and delete your pods. You can go ahead and delete your services. You can go ahead and issue commands against your cluster using kubectl. Now, in this chapter, I just want to quickly go through the logging aspect when it comes to Azure Kubernetes. So when you go ahead and create your Kubernetes cluster, it will actually go ahead as part of the wizard and also create a log analytics workspace. That log analytics workspace will actually go ahead and take all the logs about your containers, about your nodes, etc. So if you actually go on to all resources, if you go ahead and actually create a cluster, I just want to go ahead and show you where this setting is during the creation. So I'll go ahead and choose Kubernetes service. So I'll just quickly go ahead and choose the details. I'll leave everything as it is. I'll go on to next for node pools. So leave everything as it is. I'll go on to the last section, which is integrations. And over here, you can see that when it comes to container monitoring, by default, it is enabled and it will go ahead and send the logs onto a log analytics workspace. So it'll actually go ahead and create that log analytics workspace for you. So in another tab, I already have a cluster running. So I have some containers that are also running as part of the cluster. Now, if I go on to all resources, if I go ahead and just search for log, so I want to go on to the log analytics workspace that gets created for this cluster. Now over here, if I go ahead and scroll on to the log section, let me go ahead and just hide this. Over here, you will see now the tables when it comes to container insights. So when you go on to container log, here is where you can actually go ahead and see the logs about your container. So if you actually go ahead and type in container log, so just the table itself, let me go ahead and just hide this and click on run. And over here, you will see all of the rows of data. So for each data over here, you can see the time that it was generated, on which node it is actually running. So remember, these are running on your underlying nodes. Over here, you can see the container ID and other aspects as well. Now, just for the purpose of the exam, I'm just going to go ahead on to a few statements when it comes to the logs itself. And yes, I said I do know that Azure Kubernetes is not an objective in the exam, but then I still saw a question based on logging when I gave the exam. So that's why I just want to ensure that you are prepared. So over here in the first statement, I just want to go ahead and look at the data in the container log, where the time generated was greater than the timestamp over here. So I'm just declaring a variable over here saying that I want to go ahead and basically look at the information in the past 1 day, in the last 24 hours. So if I go ahead and just run the statement quickly over here, and let me go ahead and hit on run. So I'm getting the data. So this is the data for the past 24 hours. Now, the next statement that I have is I want to get all of the container IDs. Now over here, the container IDs will be in the table of kube pod inventory. So remember, all of your containers are part of pods, and the information about the container IDs and the pods is there basically in the container log. But the container ID itself, all of them are basically in the kube pod inventory. And over here, I'm saying where basically I want to get the containers based on my cluster, and I want to get all of the distinct container IDs. So over here, if I go ahead and just run this statement now, Right, so I'm getting all of the distinct container IDs. Please note that this will also go ahead and represent the system containers that are also running. Now next, I'm trying to go ahead and now combine the queries. So over here, I'm saying, please now go ahead and get the logs of the containers where the container ID is basically in the containers ID that I got over here. So now let me go ahead and copy these statements. I'll go over here, and I don't need now the container IDs over here because I'm already going ahead and basically making a reference on to container IDs over here. So let me go ahead and click on run. Let me go ahead and select everything and then click on run. Right, so we're getting the data in place. Now finally, I'm going a step further wherein I want to go ahead and look at all the data based on the computer. So I'm summarizing the count by the computer. So remember, this is the underlying nodes in the cluster. So let me go ahead, delete everything, enter the statement, and then click on run. So now you can see the containers are just basically running on one node because I only have one node in my cluster. Now I said the purpose of this was just to go ahead and explain some of the queries which you can go ahead and use when it comes to querying your containers. So again, we're not going to go into depth because I said this is a one-off scenario when this comes to purely an exam perspective about understanding logging when it comes to Azure Kubernetes.